No, that could be 6. You're right. I don't know why they didn't combine them. Yeah, I don't know why they didn't combine those two. Yes, those two should be combined. All right. What kind of line is that? Linear horizontal, right? It's a horizontal line. Okay. So that would be any equation, any problem in the form of like y equals 3, y equals 5. It doesn't really matter what the number is, right? Just y equals any kind of constant. So y equals c, correct? And the slope of every one of those lines is what? Is 0, right? Because it's a horizontal line. We know from our algebra classes way back when that the slope of a horizontal line is 0. So we're now moving into differentiation. What does differentiation tell me? The slope of a line. So if it is a constant, the slope is always 0. So if I have f of x is a constant, the f prime of x, or the derivative of that, is always 0. So the derivative of a constant is 0. Okay? Rule number 1. We're going to look at a whole bunch of derivative rules. That's the first one. Should also be the easiest one. I will copy the official rule from the book. So the derivative of a constant is 0. And remember, there's a lot of different ways you can write derivatives. You can write dx. You can write f prime of x. There's a lot of different ways you can write them. But they all mean the same thing. All right. Now, let's go back to what we just did over here. So the constants are simple. Actually, we'll do one more before this one. What if I had a simple line like that? Just y equals x. What's the slope of that one? 1. So is it ever not going to be 1? No. So the f of x is x, then my f prime of x is 1. Okay, because it's all stays the same, right? Now, what if I had the f of x equals 2x? What would be the f prime of that be? It would be 2, right? Again, we're just telling us the slope, correct? Now let's go a little more complicated. Those are the simple ones. All right, so we did this equation last class, correct? Remember that equation? That was the f of x plus 4h minus f of x over h. We were plugging numbers into that. We were factoring out the h to cancel things out. That's what we did last class. Let's change this to 4. So you just did f of x plus h to the 4th power, which was here. We just did that. And we're going to subtract the x minus x to the fourth on the top there. Do you think it would matter if this was x to the fifth, x to the sixth, or anything else like that? It would be the same process, right? Okay. As long as everybody agrees with or believes that. So what's the first thing I can cancel out now? Right, I can cancel out the x to the fourth, right? Those are all going to be gone. And no matter what x to the was, that was always going to be gone. What do you notice that every other term has in it now? As well as an h. So let's pull that h out. And if I had that all over h, the h's are now going to cancel out, correct? Okay. We are doing the limit as h goes to 0. So all the h's that are left are now going to become zeros, correct? What's the only thing left? 4x to the third is the only thing left. Okay. So when you were going through and multiplying them out, the first term, that x whatever, is always going to cancel itself out, right? Because I'm always going to have minus it at the end. So this piece right here, that piece and that piece will always cancel each other out, correct? Every other term is always going to have one h left in it, at least one h left in it, correct? If I factor them out, the only term that's not going to have an h left is the one that had just one h, which will be the next degree down, always. It'll always end up being that. So if this was x to the fifth, it would have been the x to the fourth term. Or if it was x to the seventh, it would have been the x to the sixth term, whichever which one's left. Because if we look at the degrees here, every degree equals 4. That makes sense? Okay. So, what do you think the rule is? So if I have f prime of x is x to the n, or sorry, not f prime of x, f of x, is f of x to the n prime. Yes. Yes. Well, we know it's going to be n minus 1, right? It's always subtracting the 1. Okay. So that will always be whatever the degree was. Yes. So this right here is known as our power rule. There it is, nicely written in book language. It says the exact same thing. So the derivative power, x to any power, doesn't matter what the degree is always going to be n to the x to the n minus 1. Always one less degree, and the degree comes down in front. The original degree comes down in front. Now let's think about that in terms of what we just did a little bit ago with the linear equation. What's the degree of a linear equation? It'd be 1, right? What's 1 minus 1? 0. So that degree is gone. So that x term is gone. And all that was left would be whatever number was there. Okay, so this even works if it was just f of x equals x. This rule still works. This rule works for any degree. Okay. So if we didn't want to have to go through all I gave you f of x equals x to the fourth, we instantly know, based on that rule, that answer is 4x to the third with no extra work. So what's the degree if it's x to the seventh? Seven x to the sixth. You bring the degree down and then you subtract one. You always bring the degree down first and then subtract one. Yes? We're not going to get there yet. I will do that one tonight, actually. But not yet. What about this one? So if we follow the same rule, right, it'd be negative 2x to which power? Negative what? 3. Same rule applies. One of the crazy ones that they tried. Yes, I'm going to show you that one in a second. I want to do one of the ones first. Oh, actually, let me do one piece before this one. Remember, x to the negative second is the same thing as saying 1 over x squared. Everybody remember that? Negative exponents are just numbers in the denominator. We can move them up. That's actually going to become extremely important because that's going to save me having to do different rules if I can bring things up top. What about the square root of x? What's the exponent for the square root of x? 1/2. So that is the same thing as saying x to the 1/2. So then my derivative of that would be what? Right. 1/2 x to the negative 1/2, which I could rewrite as 1 over 2 square root of x. Move it down and change it back to the square root. And this actually would be negative 2 over x to the third. There it is. Remember that rule? If I have a constant with the limit, I can pull the constant out and just do the limit of the thing inside. So if I had that, that's the same thing as saying 4 times the derivative of the f of x without. Okay. Or actually, I should write it this way. 4 times d dx of x to the third. So I can pull out the constant and do the power rule. So this would be 4 times 3x squared, which would be, in the end, 12x squared. Okay. So even if there's a constant in front, I can pull out that constant, do the power rule, and then put it back together. What were the other things that I could separate with the limits? I can separate addition and subtraction. And I can also do that same thing with, so if I have addition and subtraction, I can separate them, do the derivative of each of the pieces, and we'll be fine. All right, let's say a good job. Find my derivative. All right, so let's look at this in pieces. What's the derivative of the first one? 8x to the 7th. The next one would be 12 times. What's the derivative of x to the 5th? Yeah, 5x to the, multiply times 12 in a minute. Minus 4 times, what's the derivative of x to the 4th? Plus 10 times, minus 6 times, 1. And the 5 is 0. So we get 8x to the 7th plus 60x to the 4th minus 16x to the 3rd plus 30x squared minus 6. Want to go back and do that with the limits like we did it last week? Imagine having the x to the h's and all those, and you have to, yeah, you'd be here forever. That's why I said you're never going to do that. I just did it so you understood it, so I can explain to you the rules for that. That's the derivative. Okay. So now the question is, okay, who cares? We found the derivative. Yay. There's the function for that graph. how would I find the 3 points where I have a horizontal tangent? Yeah. And be what? Yeah. So I find the derivative, right? And set it equal to 0. Because if the derivative is 0, I have a horizontal line, right? So let's take that equation, find my derivative of it first. So what's my derivative? And the 4 is gone, right? So let's think about this. What if that was plus 10? Would that change where these lines are? Yeah. Huh? That's what we're talking about right now. If this was 10, all that does is shift the equation, right? It shifts it up and down, not left and right, correct? So does that change my derivatives? No, because I'm just taking the whole graph and shifting it up or shifting it down, correct? That's what that last number does. Since it doesn't impact the derivatives, because it's a constant, remember what we said about the derivative of a constant. What's the derivative of a constant? Very first one was 0, right? So that constant can disappear in any problem because all it's doing is shifting it up or down. And we don't care where it is on the graph. All we care about is what the slopes are at any given point. Okay? So shifting it up or down does not change my slopes. Shifting it left and right actually doesn't change my slopes either. All it changes is if we're going to solve for the values where the x would occur. So that will change my answers a little bit for this problem. So that's where that 4 goes. It disappears because it is a 0. That's going to become a very big deal when we have to go backwards later on. We start talking about integration. Because when we're taking the derivative of something, that term goes away. So when we go backwards, now we don't know what that term is. So that's where that plus c and stuff comes in that we'll talk about later. All right, so but we need to figure out these 3 x points. So as you said, I got to set this equal to 0, right? So I want to know when this is 0. So 0 equals 4x to the third minus 12x. Okay? So how do we solve that for 0? Yeah, let's factor something out. What can I factor out? I can factor out 4x, and I'm left with x squared minus 3. Now that it's factored, we can set each term equal to 0. So I have 4x equals 0, and x squared minus 3 equals 0. So 4x equals 0, that means x equals what? 0. And that would be that term, that point, which is good. So that's x equals 0. This one, I have x squared equals 3. What do I do? How do I get rid of the square? Square root. So x equals what? Right, plus or minus the square root of 3. And that's going to give me that one. So those would be the 3 values. Now, technically, you could do this for any number. I just did it with the horizontal line because that's an important piece of information for my graphs. But I could look at this and go, okay, where does the equation equal? Where does the derivative equal 4? Might make it a little more complicated to solve. We might have to do quadratic formula and stuff like that, but we could do it. Okay, so like you can use it technically to solve any value of these. We're going to do it most often at 0. That's what it's going to use most often. All right. Since you asked. What's the derivative of this? Huh? Not this one. Ah, that was different though. That was the square root of x.
Oh, okay.
That's okay. Like, oh, what's the rule say? N to the x and the n minus 1, right? What's n in this case? Square root of 2. So that goes in front. And that's x. And what's up in the denominator or the exponent? Square root of 2 minus 1. That's it. I know it looks weird. The power rule is deceptively simple. And it's also one of those ones that where you're going to use now forever. Like anything you're doing in calculus, I can almost guarantee you're going to use the power rule. Yeah. 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 Yeah, chemistry, organic chem. I remember my sister taking organic chemistry and me literally teaching her calculus. Yeah. Me teaching her calculus over the phone because she couldn't remember how to do it all. All right. What about x to the pi? Like, why? Same thing. You can blame him. It's all his fault. And the only reason I didn't do this first was because a lot of people don't know what E is. It is a constant. It's 2.718 or something like that. So like okay. It is a constant. It is no different than pi. It is no different than the square root of 2. It is no different than 5. So, and the way the power rule goes with x to the e, it would be e x to the e minus 1. That is literally how it would be written. Okay. So what if f of x was e to the x? What's different between this and what we've just been talking about? The x is in the power. Because the x is in the power, I cannot use the power rule. Okay, so this is not x e to the x minus 1. Okay, the power rule states the exponent has to be a number or a value. It cannot be a variable. Okay, in this case, it's a variable. The base is a constant, the exponent's a variable. And because I'm not going to go through the entire rule, I want to. So that is actually the definition of E. Okay, that is actually the definition of the number E. Because that comes up later on, so knowing that actually is kind of important. But for what we're looking at right now, the derivative of e to the x is actually just e to the x. Okay, so this would actually literally have just been f prime of x is e to the x. It is actually the only term that the derivative of it is exactly what you started with. And nobody wants to ask me why. Trust me, the proof's not that easy to understand, so that's why I'm not going through the proof. Just take this one on faith. Yes. Yep. Also a very cool thing. Makes your life a little bit easier when you're dealing with UDDXs. All right. What's f prime of x? So remember, it's just in a subtraction, we can split things up, right? Look at them in pieces. So we know the derivative of e to the x is e to the x. What is the derivative of x? 1. So it's minus 1. What's the second derivative? That's the derivative of the derivative. So this would be just e to the x, and the derivative of 1 is 0. All right. I've taught you everything I need to teach you tonight. Now we're going to do some problems. Now I'm going to have you guys do some problems. So I've got s is 2t to the third minus 5t squared plus 3t plus 4. I want the acceleration. Which derivative is the acceleration? Or what's the derivative of the position? So it's the change in x over the change in y. That's slope, right? But what would we call that? That's velocity, right? So velocity is your first derivative. What would be acceleration then? Acceleration is your second derivative. So find me the second derivative of that. Yeah, no, you're not saying the second derivative equal to 2, t is 2. They're actually going to Walks. Actually. I think you check the third one. There you go. Okay. I was like, wait a second, we lost the X. Huh? Yeah, but that's his talk. Yeah, because remember, yes, that's just one step, yeah.
Oh, so is that just the one?
Yeah. Yep. All right, so we've got 6t squared minus 10t plus 3. And then 12t minus 10. And we're looking for the acceleration at 2, which would be 14. And it would be centimeters per second squared. Is your acceleration. Good. All right. So I said there's no point in even coming. Because I knew I was going to get through this quick. The reason I don't want to go on to the next one is the next one is not that simple because it's the product and the quotient rules, which are not that simple. And I'm not going to try to do those in 15 minutes or 20 minutes. So we will do those on Wednesday or Thursday. All right, let's give you a couple ones to make you struggle. You know, those fun things. Let's do this one. This one. Let's have you start with those two. All right, let's see what you got. Let's see what this one's fine. This one's fine. We got. Give you a little more. This is the crack. Give you a little- this is the crack.
Oh, yeah.
Give you a little more here. This is fine. Actually, that's totally fine. The way you did it. Yeah. Yep. A little bit of a roundabout way to get there. It worked. That's- Oh, okay, never mind. I got you. You're right. Yes, that's fine. Okay. That's fine. But you have to do the. Get those two. You just do. Yeah, you didn't actually take the order. Take the order that. What's the order of that? Oh, you did the algebra. Which I understand, because like, wait, there's a whole bunch of stuff, right? Okay. Yeah, you can't do the. I didn't. Anyway. You did the same thing. You can't do the derivative because you don't have. So, so not everybody say it. So we only have rules for addition and subtraction to split things up. We do not have a rule to split up the multiplication or division. So I'm only giving you two rules. I gave you the power rule, and then I told you you can split everything up as long as it's addition and subtraction. So somehow, the first thing you got to do in those two problems is get rid of all the multiplication and division. That's your very first step. The multiplication division have to disappear. And now you understand why I said the algebra is going to be your guys' downfall. Okay. So that's x to the fourth, and then we should have 3x to the third. Right? But that's it. I'm not sure where. You've got an extra, you have an extra term now. So, okay, hold on. You multiplied that times that x to the one. But you didn't multiply x to the third.
Sure.
And then you did the derivative of something and then did it again. You did. Yes. Oh, you're making it like way too difficult. You will get the right answer. As long as you don't make a little mistake anywhere in the path. Okay. Yes, that's fine. Let's get that first.
And you're the first one to actually get close to where the answer is. Yes. Uh, 9. Oh, is that 9 or 4? 4. Yeah.
So algebra first. Just distribute. So x to the fourth, 3x to the third. And that's still f of x. I haven't done the derivative or anything else to it yet. Now that we've got it down to just addition and subtraction, now I can do my derivative. 4x to the third plus 9x squared. Okay. So it's just the little things. The hardest, like that's why I was telling you guys before, the hardest thing you guys are going to have is the algebra, not the calculus. I know you all know the power rule. If I give you any simple thing, you guys will all do the power rule because you've done it already. Like I gave you a problem just like that. You found me the derivative of it, no problem. The problem is that once you get a problem that is not in the correct format, then you screw up because you're like, okay, what do I got to do? Okay. That's where all the algebra skills come into play. That's where you come in as like, okay, how can I manipulate this problem to be able to use what I know? All right. Now, you could have, as she did, go literally back to the limit rule, which works. It will always work. You will guaranteed make mistakes somewhere in the math along the process because it is long. And after next class, I'm going to teach you a product rule and a quotient rule that will help you as well. However, those rules are longer and harder. And sometimes it's easier to get the things simplified down with the algebra than to do the product rule. Okay, so like on this first one, it was a lot simpler just to distribute it and do that, the power rule for it. As long as you think to do that. What about the second one? We have division, right? But again, I can start to look at how I can use algebra to manipulate this. You can do this one of two ways. Okay. One way is we can change this to multiplication. What did I tell you about exponents in the denominator? The exponent is negative. So I can change this problem to x to the negative second times, and then I told you the square root is 1/2 plus x. I can change it to that. The other way we could do it is I could just do x to the 1/2 x squared plus x over x squared. I can split up the denominator to both pieces. Okay. Either one of these is going to come out to be the exact same answer in the next step. Because now I can distribute, or I'm going to subtract because of the division. So I have x to the negative 3 over 2 plus x to the negative 1. And now we're right back to addition and subtraction, and I can do my power rule. So y prime is negative 3 over 2, x to the negative 5 over 2, minus 1, or just minus, I'll put the 1 so you go, x to the negative second. The key is you have to get them back to addition and subtraction. All right. Let's do. Let's do this one. All right, try that one. Think you guys got your answer? Let's see.
Oh. Okay.
That's fine. That's what I thought. So actually, that's fine. That's even. Or negative, I'm sorry, excuse me. I'm gonna explain this one. You're not the only one that did that mistake. Actually, I think that most people have all made that. mistake. Oh, I see. square roots to screw everybody up. Yeah. Yep, you too.
What's the square root of 25 equal? 5, right? Okay. What's the square root of 9 equal? 3. What's the square root of 5 equal? The vast majority of you put 2.5. Because you did 5 divided by 2. Okay, so no, square root of 5 is not 2.5. It is just the square root of 5. Square root of 7 is not 3.5. It is just the square root of 7. You can't do it. It's a constant. It stays there. Okay, yes.
I did that, but I did it after I changed the power one half.
And that's fine, but you still aren't dividing it by 2. It's 5 to the 1/2 power. It's not 5 divided by 2 or 7 divided by 2. But you can't do the power rule because it's a 5, not a x or a variable. That's the piece. So that was the second part of this mistake. So when you're looking at this problem is the square root of 5 times the square root of t, which is the square root of 5 t to the 1/2. Don't change your constants with the exponent. Okay. The only thing you're worrying about exponents is your variables. That square root of 5 is no different than the number 3 or the number 10 or any other thing that I could put in front of a t or an x. Okay. It is just a constant. Okay. Which means the other side of this problem, when we're just bringing up the -1, is just the square root of 7t to the -1. One nice little way so you don't screw up and realize things are under it. That's why I put that little flag there. It just means it's not continuing because it's really easy to think it goes over everything after you write it. So it's a nice little thing just to remember. Nope, it's stopping. Now we do our derivative. But remember, our derivative is only on the variables. The constants are just staying there. So this is the square root of 5 times 1/2 t to the -1/2. This is the square root of 7 times -1 t to the -2nd power. So when you write your final answer, we get square root of 5 over 2, and you leave it like that because it's over 2. And then you can put the square root of t down the bottom if you want. Plus, or actually minus, square root of 7 over t squared. That is g prime of t. No. I'm not that worried about that at this point. Because there's actually some situations where you'd want to take that and change it back to 5 over 4t, depending on what you want to do with it afterwards. So I wouldn't worry about rationalizing it at the moment. All right, I won't give you another one with square roots. Try this one.
You have to get rid of the. That's that. I know, but that is that. Because you have to have a negative three, so I'm at 4. Okay, that. That. Yes. It's very much. Uh, Pepper. Pepper, I should choose one of the top. You brought it up. Or split it up. You can't do very much of it. But your goods are there, you're out. And you gotta focus up there. Oh. Yeah. Because you can be back to a level 4. All right. Having fun yet? You're gonna remember all those algebra rules by the end of this class. All right. 4t to the third is not 4t to the third. Okay, that is not that. It is 4 to the third t to the third. Okay, which would be 64 t to the third. That also means that you cannot bring it up top as 4t to the negative third and then somehow go to 4t to the negative third, because that's no different than saying that, which is not correct. Okay, so that would be negative 4, that would be that, which you then would end up getting 1 over 64 somewhere in there and have another fraction that's going to cause you trouble. Okay, so there was 2 ways I showed you to do this problem. You want to look at it this way. Okay, this one worked really well because there was no constant or anything else. There was no parentheses down the bottom, so I could bring it up and distribute it. It's fine. A lot of times the fractions don't work that well, so we can split up the denominator and then work with each piece individually. Okay, so for this one, we want to change this to 1 plus 16t squared over 64t to the third first. Start there. Now, split this up. So we have 1 over 64t to the third plus 16t squared over 64t to the third.
Okay. Then we can deal with the t's and put them together and get the negative t's. So you have 1 over 64, t to the negative third, plus 1/4, t to the negative first. Manipulating the problems is going to save you a lot of work if you remember how to do it. And in derivatives and differentiation, there's a lot of situations where we will not be able to do the problem unless we simplify. Okay, because there's only so many rules in differentiation. Integration, there's an absolute insane amount of rules we can use. In derivative differentiation, there's not, because it's expected that you manipulate the problem down to a way that you can do it. Okay, like this one, we will have a quotient rule. You could absolutely do the quotient rule for it. It is not going to necessarily be any. It's going to actually be harder than this. And even at that point, you're still going to have to simplify the problem down at the end because you're going to get this long problem that you're going to have to break down. So in the event, it's still going to come out to be the exact same as this. All right, so now that we've got it to a place where we can actually do the derivative of it, how do I do the derivative? 64, negative 3, t to the negative fourth. It's 1/4, negative 1, t to the negative second. So negative 3 over 64, t to the fourth, plus or minus 1 over 4 t squared. And you can leave it like that. You don't have to put them back together. Remember, square root is just multiplication. Yes. Very good. Okay, oil splitter. All right. This is. I'm going to make X because I don't feel like writing the Q's because I'm screwed up. So I've got 1 plus x to the negative 1 plus x to the negative 1 plus x to the negative 2. So therefore my is 1 minus 2 x to the negative second. It's not 1. Negative 2 x to the negative second minus 2 x to the negative third. All right. One more. Because I haven't done one like this.
I wouldn't say that it's.
Oh, I like it. Not really. At least I understand. At least I have very good. All right. I wasn't expecting anybody to get it, so it's fine. But again, these are
as crazy as it sounds, all rules you actually learned at some point. What is e to the x plus 1? So there's a function inside of things. So we know e to the x just as e to the x, right? When we do the derivative of it, that's fine. Problem is e to the x plus 1 is not e to the x. That is e to the first times e to the x. What do you do when you multiply like bases? You add their exponents. So if I gave you, say, 2 to the third times 2 to the fifth, that's 2 to the 3 plus 5, or 2 to the 8th, right? So if I went backwards, that would be that. Okay? What is e? In general, what's e? It's a constant. It's just like pi. It's just a number, right? So I have there. What's the derivative of e to the x? It's just e to the x, right? And e is a constant. And that 1 disappears. You can write back as e to the x plus 1. What was this one? This one was. So yeah, this one does. So there was a reason why when everybody had e to the x plus 1, I was like, you're like, it's, well, we're sure it's this. And yes, the only reason that made sense that way though is because it was just x plus 1. You can't go directly from here to here. Okay. So you had to have some reasoning on how you could get to there. And that's that. Okay. All right. So now go practice your algebra skills. Fractions, parentheses, distributing, all those little things. I told you the hardest part of this class is not going to be the differentiation of the calculus. Those are simple rules. It's being able to manipulate your problem to a point where you can actually solve it. All right. I see you Wednesday. Oh, yeah, absolutely. Last name.
Elton, M-E-L-T.
Oh, yeah. If you want your test, come see me. There you go. Last name. What was it?
Or together.
Corey. Did I give you 2? Yeah, check your test. I don't have yours. And I know you did it. Hold on. Last name.
So if I go.
Alex, right? Last name. Huh?
Echeverria. Diego first. Probably just flip that first.
Last name. Last name.
Yeah.
Last name.
Fuentes.
Last name.
Oh, there I am.
That one?
Benjamin.
Oh. Okay. Sorry. There you go. Never mind. We're good.
But did you put in Blackboard already?
Yes, it's all Blackboard. Last name. Thank you.